Hello, today we will discuss problem B2 from US Physics Olympiad 2009 USAPHO Semifinals. That was the last problem for this semifinal, the last of 6. Problem. An electric dipole consists of two charges of equal magnitude Q and the opposite sign held rigidly apart by distance d. The dipole moment is defined by P equal QD. Now consider two identical oppositely oriented electric dipoles separated by a distance r, as shown in the diagram. Question A. It is convenient when considering the interaction between the dipoles to choose the zero of potential energy such that the potential energy is zero when the dipoles are very far apart from each other. Using this convention, write an exact expression for the potential energy of this arrangement in terms of Q, D, R, and fundamental constants. Question B. Assume that D much less than R. Give an approximation of your expression for the potential energy to lowest order in D. Rewrite this approximation in terms of only P, R, and the fundamental constants. Question C. What is the force, magnitude, and direction exerted on one dipole by the other? Continue to make the assumption that D much less than R, and again express your result in terms of only P, R, and the fundamental constants. Question D. What is the electric field near dipole B produced by dipole A? Continue to make the assumption that D much less than R and express your result in terms of only PR and the fundamental constants. Solution. For the first question, we can write down exact expression for potential energy. That will be this expression. Here we have first member, that's the interaction between this charge and this charge. Next is this charge and this charge. After that we have this charge and this charge, and after that we have this charge and this charge. So we have this equal this equal this. We have totally this expression for total potential energy. For the next question, we have to express formula for small d compared to r. We can use here this approximation for 1 over square root from 1 plus a small variable. That will be this one. When we put it here, we will get result. This is our original expression. We can represent it like this one. Take 1 over r out of this scope. And now use this formula to represent this approximation. So finally we have this expression. Negative p squared over 4 pi epsilon 0 r cubed. Next question C. What is the force, magnitude, and direction exerted on one dipole by the other? Continue to make the assumption that D much less than R, and again express your result in terms of only P, R, and the fundamental constants. Due to symmetry, we have zero force in y direction. We can have only x direction. So we just need to take a first derivative. that will be this expression for force. Like we can see, first 3 questions, they were not very hard, but question D, it needs more careful investigation. Let's do this. Now let's forget about the dipole B. We have to find what is electric field on this distance r from dipole A. And let's say we can make a shift in y direction by a small distance y. Now we can write exact expression for electric field in y direction and in x direction for points which are distance r from dipole and displacement y from middle point in y direction. So now we can approximate this formula due to a very small expression for d and y, and finally we will get this result. Approximately electric field in y direction equal negative p divided by 4 pi epsilon 0 r cube. For x direction we have exact this expression, and here we have finally that electric field proportional to y displacement, which we can understand because in the midpoint it must be 0 due to symmetry, but after that it must increase linearly, and this is coefficient. So that's it. Problem is done.